All right, time to review some derivatives for the Unit 3 test. So here we go. First type of questions we're going to be looking at here are these ones where we're finding all these good old features about these graphs, okay? So we want to find critical points, extrema, increasing, decreasing, all that good stuff. So we're going to need the derivative. Let's find the derivative here. And so there we got our derivative, f prime. And let's go ahead and get a number line for that thing. And, well, we're going to need to find out where it's equal to 0. So we can set it equal to 0. X squared plus 2x. All right, and I think this thing factors. That's nice. X plus 4 and x minus 2, right? And so our zeros are at x equals -4 and 2. So -4 and 2. So we found our critical values here. And so we got critical values at x equals -4 and 2. Okay, coming from the first derivative. Okay, and so let's come on over here and let's plug in values. We can plug in like -5, and -5 is going to come out to be a negative times a negative, which will give us a positive, and so that's going to be increasing. We have something in between like 0. Plug in 0 into the derivative, and we get 4 times -2, that's a negative, okay? And plug in something like +3, and we get 7 positive, so that's going to be positive, okay? So we're increasing, we're decreasing, and we're increasing, right? So that means we've got some extrema. We're going to have right here, we're going to have a maximum. So we have a max at x equals -4. And we have a min at x equals 2. We don't care about the y values right now, just those are our x values. Increasing, well, we got increasing in these two intervals here. So that's going to give us from -infinity to -4, and also from 2 to infinity. All right, we can put a little union there. And the intervals of decreasing, well, that's going to be from -4 to 2. That's where the first derivative is 0. So inflection points now, to find some inflection points, we're going to need to find the second derivative. So let's come on over here. Here's our first derivative. We'll take the second derivative of that now. And let's go on over here. Polynomial makes a nice quick derivative. Now let's set it equal to 0 and solve it. And so we can subtract 2 divided by 2, and we get -1. All right. So we're making our number line. We can get our critical values there. And we know that when x is -1, somewhere in the line we have a critical value. To the left, these are numbers like -2. So if we plug in -2, we get 2 times -2 plus 2. That's going to be negative, right? And if we plug in a number to the right, like 0, well, we're going to get a positive value, okay? And -1 will give us 0. So this is concave down, and this is concave up, all right? So that's our concavity. So we can come over here. We do have an inflection point because it changes. Inflection point is at x equals -1. Interval is concave up is going to be from -1 to infinity. Concave down would be from -infinity to -1. All right. And there you have it. Okay. There's a polynomial. Not too shabby. Should be pretty quick to do that. Now let's go ahead and try a rational function here. All right. Let's find those key features for a rational function. When you're doing a rational function, it's definitely helpful to be thinking of the graph. All right. The polynomial, you can think of the graph too. You think of the end behavior and some things we know there. You know, here we had a third degree. So looking at the graph here, we know it's third degree. And and it's a positive leading coefficient. So, you know, we're probably looking at something like this. Okay? And so that matches our increasing, decreasing, and so on and so forth. So keep in mind on the graph. All right? So here we go. Key features here, well, the denominator here factors into x plus 1, x minus 1. And so it's undefined at -1 and +1. All right, so it's undefined. We're going to have some asymptotes there. Rational function, we kind of expect that. Okay, now we want to think about any horizontal asymptotes. And so we remember from pre-calculus there, if the degree is bigger on the bottom than the top, then it's going to 0. Okay, and the reason is if you find the limit, let's talk calculus here, if we find the limit as x goes to infinity, either plus or minus infinity, okay, of 2x minus 4 over x squared minus 1, okay, it's infinity over infinity right now, and so we could use L'Hopital's rule, and using L'Hopital's rule, we see that, let's get this stuff out of the way. Taking the derivative of the top and the bottom, it's a pretty quick deal. We can see this is going to 0. Okay, took the derivative here, 2, took the derivative here, 2x. That's L'Hopital's rule, all right? You can also just pretty much see. Bigger degree on the bottom, it's going to 0. This is x squared is a lot bigger than the x, okay? Anyways, L'Hopital's rule, if you know it, there you go. So you guys should know that there. Okay, so it's going to 0. So we know as we go to infinity, that is going to 0. Good to know. All right, so some critical points. Let's find some derivatives. Let's find f prime. We're going to take that derivative of the top times the bottom and minus the top times the derivative of the bottom. Moving over a bit here. And we have the bottom squared. All right. The top will clean up here. And so we end up with polynomial like this, -2x squared. That comes from multiplying these and multiplying these two x's and the negative. And you'll get that. Clean it all up, you get that. All right. So that's all over x squared minus 1 squared. No need to multiply that out, so let's leave that alone there, right? And so now we want to set this equal to 0 to find the critical values, and all that matters is the numerator, right? Okay, we notice that x cannot be 1 or -1, so we already have that. That's the asymptotes, okay? So those are critical values. Let's see, x equals plus or minus 1. So we got to put those down because it's undefined. But setting the top equal to 0, let's go like this. And we'll factor it while we're at it. Pull out a -2. And we have x squared minus 4x plus 1. All right, setting that equal to 0. You can divide off the -2, and all we care about is the inside equals 0. And that does not factor, so we'll have to use some quadratic formula. So we get 2 plus or minus the square root of 3 when we use a quadratic formula. We can also just go ahead and use our calculator, and this would be a calculator problem. And so we'll pull in our little calculator here, and we see we have, if we solve this, we get the same thing we just said there. A little different form because the calculator likes it in different form, but we get that's 0.27 and 3.73. How about that? Okay, 0.27, 3.73. All right, so put that away. And we said 0.27. Put that on a number line. So we got that on our number line, and we also have our other critical values of -1 and 1. And we're going to test that out now. This is f of x, prime of x, that is. And so we're going to test that out with our derivative to find our increasing and decreasing. So we're going to plug these in here. If we plug in some of these values, we're going to get something like this. If we plug in -2, we're going to get a negative on top. The bottom's always positive. If we plug in 0, we get negative on top. The bottom was always positive. That gives us negative. If we plug in 0.5 is between here, that gives us 4 minus 2, which is 2. Plug in 0.5 here, we get something less than -2. So this will come out to be positive, all right? So 0.5 is going to give us positive. Then we can plug in something like 2. Okay, so 2 is going to give us -8. It's going to give us plus 16 minus 2. And that whole thing is going to be positive. Plug in something like 4. When we get 4 here, we're going to get 16 negative 32 plus plus 32 minus 2. So that's going to be a negative. Again, the bottom's always positive. So there's our increasing and our decreasing. We know that our negative, our -1 and our 1, those are going to be asymptotes there, okay? And this guy is going to be going down, going to be going up here. So there's going to be a minimum there. And this one's going to be going up because it's positive, and down. So that makes this a max. So let's get that information in here. Going back to our critical values and our extrema, we can get those. And we get these guys. Okay, our intervals of increasing and decreasing. Let's get those. We just set these down here. We'll copy those from this right here. And there we go. We got our intervals of increasing. Those are our positive first derivative. Intervals of decreasing, that's our negative first derivative. Inflection points and concave up, that's our second derivative. So let's get into that real quickly. So let's come over here looking at our first derivative right here. Okay. And let's use the quotient rule yet again. All right. So using the quotient rule for this guy. Derivative of the top, we get -4x plus 8 times the bottom, x minus 1 squared. Then we're going to get the top. Let's see, we need to move this. Then our second parts, we have, we got a minus here. Minus the top, which is that big old ugly thing, times the derivative of the bottom, a little chain rule, derivative of the inside, 2x, times the derivative of the whole thing down here, drop the 2 down, and x squared minus 1, all over the bottom squared. Okay, let's go ahead and clean this mess up. So we can pull out an x squared minus 1 because it's there and there. We can pull out a 2. I'm going to pull a 2 out of there, leaving us with a negative 2x plus 4. And then this 2 gets pulled out. This thing got pulled out, and one of these got pulled out, leaving half of this, and one of these guys leaving this thing here, and almost forgot the 2x. All right, let's go ahead and cancel that, maybe with one of those, just so I don't have to write as much. This is getting ugly. And clean up the inside. It looks something like this. Just noticed something that you probably noticed a long time ago if you're paying attention, if you're awake. I'm not awake. I don't know where that squared came from. That was just plain old 8x. So distributing that through and multiplying that out, we get these guys here. And let's finish it off by just combining these crazy things. Don't leave behind that denominator there. All right, and we get a positive 2x cubed. We get a negative 12. We get a 2x minus negative 4x. Oh, that's going to be a 6x. And we have a negative 4. Okay? All over this x squared minus 1 cubed. Okay? Now, we want to find our critical values. So let's set that equal to 0. Okay? And so all we care about there is what makes the top 0. Let's go to our calculator. Don't try to mess with that. Go solve that thing in your calculator. So pulling this in from our calculator, we get 5.52. All right, so 5.52. All right, let's tuck that guy away. That's good to know. So 5.52. Only one answer. 5.52. All right, so our critical points for the second derivative number line are still negative 1 and 1, because that makes the denominator 0, and then 5.52. Obviously not drawn to scale here. We're not worried about that. Our number line is just so we can test some things out, okay? So let's go ahead and test it out real quickly. Looking at this big ugly guy, plug in like negative 2. Negative 2. That's going to give us a positive on the bottom. That's good to know. Okay, negative 2 in this big old thing gives us a negative. This whole thing will be negative, like 24. This will be a minus 12. Minus, everything's minus. So minus, minus, minus on the top, so that's negative. Okay, plug in 0. Oh, we like 0. Zero's in between here. And the top will be negative. So zeros, negative 4. On the bottom will be a negative. So the top was negative because it'll be negative 4 times 2. The bottom will be negative because it's negative 1 cubed. So negative over negative, positive. All right, plug in something in between here. Let's try positive 2. All right, positive 2 is going to give us 4 times negative. That's negative 48. This is going to be a positive 16. This is going to be a positive 12. And negative 48 is bigger than 16 and 12 put together. So that's going to make this negative. This thing inside is going to be negative. Okay, plug into here. And this is going to be a positive number. We'll get negative over positive. And so we have negative. And then plug in something like 6. Okay, 6. Bottom's going to be positive. We're going to get, 6 cubed is 216 times 2 is 2 times 216. Here, this is 6 squared. Oh, notice this. This is 2 times 6 right here. So this is really 2 times 6 times 6 times 6. This is exactly the same as that. Those cancel each other out. That helps to know some factoring, okay? 2 times 6 times 6 times 6. That's the same amount as that. Whatever the number is, I don't care. They cross out. 6 times 6 is 36. Hey, this whole thing is going to be positive. So we said positive over negative. And so this is going to be negative. Wait a minute. I said positive here. And this is going to be positive. So positive over positive. That's positive. Okay. Whew, I think we got it. All right. So let's go ahead and get this in here. We've got an inflection point, and that's at 5.52. And we got intervals of concave up, and that's from negative 1 to 1, and then from 5.52 to infinity, okay? And so, what does this mean after all this craziness? Well, we've got this. Let's look at our graph here, okay? Over here, we know we've got these asymptotes. We know we have a minimum at 0.27. If I find a y-intercept, plug in 0, I get -4 over -1. That's up here at 4 somewhere, wherever that's at, okay? And then I know at 0.27, right about over here. Okay, let's zoom in a bit here. At 0.27, we get a minimum, and we know we are concave up in the middle. So we got to go down to a minimum, and then we're going up. And then we're going up from there, okay? And then we know, what else do we know here? We have a maximum at 3.73. We got an inflection point, okay? And we are increasing from 1 to 3.73. So we've got a maximum somewhere over here at 3.73. We're increasing, okay? And then we're going to come around here. We're concave down. We have an inflection point at about 5.52, okay? So at 5.52, it's gonna flatten out, because as we go to infinity here, this whole thing is going to 0. Going to infinity, this going to 0 because the bottom's bigger than the top, okay? And then, so we got an inflection point, we got a maximum. Over on this side, we don't have a maximum at all. It is decreasing from negative infinity to -1, right? And we also know that it's going to 0. When we go to negative infinity, this thing's going to 0. So it's decreasing, and it's going to 0. So it's got to be looking like that. Okay? There's our crazy-looking graph, all right? Now, that wasn't asked for there, but the sketch helps clear that up a little bit. Okay? And so go to your graph, and believe it or not, we'll get something that looks like that. All right? So great job. That was a big one, okay? And we want to use our calculator in here on this stuff to solve these things. I suppose we could have even used our calculator to simplify this, take the derivative of that. But there you have it, okay? Hang in there. You're getting it. You should be proud if you made it through that thing. All right, now we have a radical function, actually a product of a radical and a quadratic, and we've got to find the key features. So let's find our derivatives first, going for our first derivative. And before we get too far, we should probably rewrite this as -2x squared, 5 minus x squared to the 1/2. And let's now find the derivative. Let's use the product rule. And here's our first derivative. So derivative of the first times the second plus the first times the derivative of the second, chain rule. We have -2x. Derivative of the outside. This is the inside. Derivative of the outside gives us 1/2. And times 5 minus x squared, -1/2. All right. Now, before we go too far, we need to notice the domain here. The stuff on the inside of the square root has to be greater than 0. So 5 minus x squared has got to be greater than 0. So 5 is greater than x squared. Okay. So what that means is we're going to take the square roots, both sides, and x has to be less than the square root of 5 and greater than -square root of 5. Okay, so that's something we got to watch out for. And so as we're dealing with that square root of 5 is going to be some important numbers there. Okay, so we're limited to that little window. Let's clean up this first derivative here. Let's go ahead and factor out the smallest power of this and see what we get. We'll also keep in mind that this cleans up to x cubed with a 2. All right, so we'll factor out a 2 x, that's what we have in common there, and the 5 minus x squared to the negative 1/2. And this is what we end up with here. So there's our f prime. Let's clean it up a little bit. We'll drop this downstairs. So we have 2x. And we've got inside, we'll have x, let's see, it'll be 3x squared minus 10. And on the bottom, 5 minus x squared to negative 1/2. All right, so there we have our f prime. Let's go ahead and set that equal to 0 and get our critical values. So we know we're looking at negative square root of 5 is our left endpoint, and square root of 5 is our right endpoint. Set this whole thing equal to 0. What makes the top 0? 0 does, so 0 is a critical value. What makes this second part 0? Well, we have 3x squared minus 10 equals 0. Solve that up, you're going to get x equals plus or minus the square root of 10/3. And that is approximately 1.83. Plus and minus, okay? And so 1.83 lives about right here, okay? Because the square root of 5 is about 2 point something, all right? So now we can test our values. Test negative 2. Negative 2 is in between here because this is less than negative 2, okay? So negative 2, plug that in, you get a negative here. You're going to get 12 minus 10. That's a positive. So this guy's going to be negative. All right, let's make that red. Plug in 1. Negative 1, that is. Negative 1 gives us negative. So that'll be positive on top, and the bottom is going to be positive. Oops, we shouldn't have a negative there. All right, fixed it. So this is going to be positive, because we have positive on top, positive on bottom. And then plug in positive 1. Positive 1, we're going to have a positive times a negative, which will make the top negative. And the bottom's always negative. And then plug in positive 2, because positive 2 lives in here. We get positive, and positive, so that's positive. So we're going down, we're going up, we're going down, we're going up. That makes this a minimum. This is a maximum at 0. We have a minimum, and there you have it, all right? So we can go ahead and record that information here. We'll do that. And so there's all the things we just talked about there. Critical points, that's all these ones down here. Mins and maxes come from increasing and decreasing. Increasing and decreasing comes from a negative first derivative for decreasing, positive first derivative for increasing. All right, so let's find some inflection points and concavity. That all comes from the second derivative. All right, so let's go find the second derivative. To do that, let's take this thing and let's go ahead and unsimplify it. All right, and so we're going to get something like this. Better word than unsimplify would be expand. Here's an expanded version of it, all right? So let's find our second derivative. Another quotient rule. That's what makes this a little cumbersome, is using this quotient rule. Okay, if you wanted to make this a negative 1/2, you could use the product rule and put it upstairs. Some people like to do that. So, all right, f double prime of x. Here we go. Let's work it out. Derivative of the top times the bottom, all that jazz. And then we're going to subtract the top times the derivative of the bottom. It gets a little challenging there because of the chain rule. And that whole deal over the denominator squared. And when we square that, well, it just becomes to the first power because it's already square rooted. All right. Well, let's clean this mess up. These guys just become a negative x here. Okay, so let's rewrite that as a negative x. That cleans up a little bit. We'll distribute that. We'll factor out the x at negative 1/2 and see what we get here. All right, so pulling some of this out here, we get pulled out a 2 because there was a 2 in there. We can pull out this binomial to negative 1/2. And that leaves behind 5 minus x squared here and no 5 minus x squared over here because we factored it out. Cut that in half. There it is. And 1/2 minus negative 1/2 is the 1 power. There it is. This negative times negative gives a positive and an x. All right. Looks like it all checks out. Want to be careful with your algebra. I won't tell you, but I've done this problem like 2 or 3 times because I've messed up so many times. It happens. Oh, well. Let's clean this up. We'll take this downstairs, and that'll be like a 3/2 power in the end there, okay? And we've got a 2. Cleaning up the inside, we get something like this. 9x squared times negative x squared, that's negative 9x to the 4th. This is going to be a plus 3x to the 4th. So negative 9 plus 3 is going to give us a negative 6x to the 4th. We're going to have some x squareds. Let's see what we get over here. When we distribute this out, we'll get a 45 plus 10x squared. So 45x squared plus 10, that's 55x squared. And when we multiply this out there, we're going to get a negative 10x squared. So 55 minus 10, that's going to be a 45x squared. All right? So we got all our x squareds. We're also going to have this constant right in here when we multiply those two guys, and that's a negative 50. All right? And that whole business is going to go over 5 minus x squared to the 3/2 power, because this is the first power, or 2/2, and this gets dropped downstairs, and we'll add it to that, okay? All right, so there we have it. We want to set this equal to 0, all right? And when that's equal to 0, we want to solve this, meaning we just want to set the numerator equal to 0. We'll go to our calculator for that. So go into our calculator here. We get these values, negative 2.4 and 2.4, negative 1.16 and 1.16. Notice, though, the 2.4 is outside the square root of 5. Square root of 5 is 2.23, so that's too small. That's positive. That's too big, okay? So we want positive and negative 1.16. There's the solutions we care about, okay? X equals plus minus 2.4, but we're going to throw that out, and plus minus 1.16. Okay, those are the ones we care about. Those are our inflection points. So let's get those down. Inflection points at x equals plus or minus 1.16. Okay, so we can find our concavity, and we got all our goodies here. Whew, almost there. F double prime of x. So we have negative square root of 5, square root of 5, and we have 1.16 and negative 1.16, all right? And so let's go back to our second derivative over here. Test some points. If we test out 0, top becomes negative, and the bottom's always going to be positive, so that's negative. Okay, so we're concave down. If we plug in a number like negative 2 here, negative 2, it's going to come out to be positive, all right? You can plug that in there. Believe me on that one, it's going to be positive. And this guy's going to be positive when you plug in positive 2 there, all right? So what do we got here going on? So we have some inflection points at negative 1.16 and positive 1.16. We're concave up from negative square root of 5 to 1.16 and 1.16 to, that's a negative, sorry, there, square root of 5. And then concave down from negative 1.16 to 1.16, all right? And last thing we'll do on this problem is we'll do a quick sketch, all right? So what does all of that tell us? Well, it looks something like this. Let's go here. Okay, here's our graph. And we know we can plug in 0 to the original function, okay? When you plug in, when you plug in 0 here, we get 0 times something that's not 0, so this whole thing is 0. Okay, so coming back here to our graph, we got the point 0, 0. Somewhere over here, we've got negative square root of 5, and we've got the square root of 5. Okay, we know we are, and then 1.16 is negative 1.16. And then right here, we got 1.16, all right? We found out that we are decreasing, okay? So we're decreasing as we go to the left. We've got a minimum. Okay, well, 1.16 is the inflection, right? Okay, so we've got, it's going to come down here. It's going to change inflection about there. We've got a minimum here, and it's going to come up, and it's going to stop about somewhere there, okay? So we're going down. We got an inflection. We got a minimum, and it's going to come back up and stop right about there. All right, little small W-looking thing, kind of handlebar mustache, okay? So here we are. Guy with the handlebar mustache there. Okay, all right. So that's the idea. All right, a lot of work, but you put it all together. First derivative gives us the mins and maxes, increasing and decreasing. Second derivative gives us inflection. All right. Okay. Let's take a break there. We'll continue with the next problems, going from a graph to graph in the next video.